Again, missing values is pretty common in real data sets. To identify missing values, we use the is.na parenthesis function, which returns a logical matrix. And to remove rows with any na values, we use the na.omit function. To replace NAs with specific values, we use the indexing with is.na as shown. For more sophisticated imputation methods, there are packages like mice that offer more, like there are multiple imputation approaches. So there are some, look, now this part of, you have a data set and you see that there are missing values. This is where, it gets more art than science. There are several different strategies that you can take. But first, you need to understand why the missing values exist in the first place. Now, that can exist because of several reasons. One is the data isn't just there. So, suppose you are collecting information based on survey, and some respondents just refuse to respond to some of the questions. So, you don't have data points there. So, that's just missing, and you can do nothing about it. In some cases, you can get missing values simply because some respondents are just not are not just eligible for certain questions. So, for example, if you are surveying MILSAPs, everybody in the MILSAPs about something, and some of the questions involve GPA, and if I'm a part of the survey and you are also a part of the survey, I'm not going to be eligible for the questions involving GPA because I'm not a student. So that missing is very different from a missing value created from the fact that I just refuse to answer a certain questions. And those can matter depending on the context. Second is it's very, very important to document your missing value strategy, like what exactly are you doing? And also later on, do some sort of an impact analysis of that. So how does your analysis change based on different different strategies involving missing values? You should always record all transformation steps and rationale. What you are doing, why you are doing, that is very, very important to get to be documented as comments in the R script, because then somebody else can take a look and see and understand what your thought process are. Data integrity is very critical. You should always create a backup before you make any major changes and verify results after each step. And there are some efficiency aspects to it which probably will not matter much at this stage because we won't be dealing with data of that size. But if you are actually dealing with observations ever, where the sample size is in millions, then you might consider some memory saving techniques. And and what happens in those more advanced cases is that there are suppose two options. You can do the same thing using two different approaches. One approach is more memory hungry than the other. Then it's probably wise to go with the one that is less taxing. These are some of the common pitfalls and some proposed solutions. Again, make sure that you are aware of what type of column you're dealing with and your choice of function is appropriate. In some cases, when you are doing some type conversion, be very careful. Make sure that the final output is what you want. Dimensions matter a lot, so make sure that number of columns and rows remain the same or change in the way you would want. Sometimes we can accidentally delete rows or columns that we don't want, so that is not desirable. And usually na.rm equals true in calculations is desired because then you are telling R to keep an eye out for missing observations. So the third and the final part of this data frames lecture. I hope this was useful. Again, I'm just scratching the surface over here. There is a lot of different nuances to it, which I'm not going into because there's no end to it. The best way to learn about this is by actually dealing with data. There are different types of data sets out there. The more you handle data frames, the more you handle raw data, the more conversant you become. So that's it from my end for the time being.